Alright, so this video we're going to look at derivatives and rates of change. Alright, so we'll be learning how to find the derivative, and let me just say before we start the video that the way that we find the derivatives in this section and in this video and in the video right after this one in the playlist, you're not going to find derivatives like this. This is using the limit to find the derivative, but you need to learn it. You need to know how to do it. Later on in future videos, you'll be learning like rules of derivatives, like power rule, product rule, quotient rule, chain rule, all that good stuff. All right, so let's go ahead and get started. So the first thing, we've got a definition: the tangent line to the curve y equals f of x at the point P, which the x coordinates A, the y coordinates f of A, is the line through P with slope m. So the slope is the limit of f of x minus f of A over x minus A as x approaches A, and provided that this limit exists. All right, so let's go ahead and take a look at the example here. So it says, find an equation of the tangent line to the parabola y equals x squared at the point 1, 1. All right, so we got to find an equation of the tangent line. So what are we doing? We're finding the equation of a line. So to find the equation of a line, which you learned this in algebra, you got to have a point on the line, and you've got to have the slope of the line. Okay, well, we know a point on the line. We've got the point here, 1, 1. Now we need to find the slope. Well, how do we find the slope? Well, that's this right here. Okay, there's your slope. All right, so we got the limit of f of x, which in this case, f of x is x squared, minus f of a. Now, remember, here's your a and f of a. All right, so that's your point coordinate. A is your x coordinate, f of a is your y coordinate, which that makes sense because, I mean, what is f of a? Well, that's just taking like this x coordinate here, 1. You take the 1, you plug it in for x, 1 squared is 1, and that gives you your y coordinate. Okay, so we've got f of x minus f of a over x minus a. So this is a, this is f of a. And so we're going to find the slope of the line. All right, so the slope is equal to the limit as x approaches a, and then see, the limit as x approaches a, and in this case a is 1, of f of x. Well, what's f of x? Well, that's the x squared. So that's x squared minus f of a. Well, what's f of a? F of a is 1 minus 1 over x minus a, and a is 1. So this is we've got to evaluate this limit to get our slope. So that's going to be the limit as x approaches 1, and then that'll factor x minus 1 times x plus 1 over x minus 1. And so this is the limit as x goes to, oh, I'm sorry, what I was doing there. As x goes to 1, and the x minus 1's cancel, so we're left with x plus 1. So this is 1 plus 1, which is 2. So there's our slope of the line. Okay, that's the slope of our tangent line. All right, so now you can see we have the slope and we have a point on the line. Now, how do we find the equation of a line? Well, that's the point slope form of the line, which, remember, that is y minus y1 equals m times x minus x1. So we've got y minus 1 equals 2 times x minus 1, which is y minus 1 is 2x minus 2, and so y equals 2x minus 1. And there is the equation of your tangent line. All right, so really the only thing that's different, that's new to you in this problem, is how you're finding the slope. Everything else you've done. Okay, all right, So we have another expression for the slope of the tangent line, which that's the m is equal to the limit as h goes to 0 of f of a plus h minus f of a over h. All right, so this is, this is an alternative. This is another way that you can find the slope using this form here. And look, honestly, to tell you the truth, as far as this right here, this limit of f of a plus h minus f of a over h, and also this one up here, in the next video or the next section in the calculus book, you're going to learn to find the derivative using the limit, and you're going to use the limit of f of x plus h minus f of x, all that over h. And basically what you'll do is you'll find the derivative like that, and then once you find the derivative, then you'll plug the number in. This section is just having you plug it in now. Okay, so let's go ahead and get started. Let's see what we've got here. All right, so let's find the equation of the tangent line of y equals 3 over x at the point 3, 1. Okay, at the point 3, 1. And we're going to use this. Yeah, you could use the previous one, but let's use this one. So we've got m is equal to the limit as h goes to 0 of what? Of f of a plus h. Well, what's a? Okay, a is the 3 here. Okay, so that's f of 3 plus h minus f of 3 over h. All right. And so this is going to be the limit as h goes to 0, f of 3 plus h. So what does that mean? That means we're going to take 3 plus h and we're going to plug it in for x here. So this is going to be 3 over 3 plus h minus f of 3. Well, let's come up here. Let's see, f of 3, that's just plugging the 3 in for x, so that's 3 over 3, which equals 1. So that's minus 1 over h. All right, now what do we have to do? Well, we've got to simplify this thing now. Okay, so to simplify this, remember how to simplify a complex fraction. We can look at each one of these as a fraction, the 1 over 1, the h over 1, and all we're going to do is we're going to multiply each term by the common denominator. And so this is going to be the limit as h goes to 0. They cancel out here. That's 3 minus 1 times 3 plus h over h times 3 plus h. And so this is going to be what? The limit as h goes to 0. If I distribute that, that's going to be 3 minus 3 is 0. And then negative 1 times h is negative h over h times 3 plus h. All right. Now what do we do? Well, we cancel the h's. And so that's going to be the limit as h goes to 0 of negative 1 over 3 plus h. And then now we can plug the 0 in for h. So that's going to be the limit as h goes to 0. I'm sorry, not limit. That's going to be negative 1 over 3 plus 0, which is negative 1/3. So there's your slope. Okay. And I'm going to go ahead and write the point down here because I'm going to have to scroll up. And see, I'm just writing this point down because I'm going to scroll up. It's going to go off the screen. So now I have what? I have my slope and I have my point on the line. Now I can find the equation of the tangent line. So this is going to be y minus 1 equals negative 1/3 times x minus 3. So y minus 1 is negative 1/3 x plus 1. And so y equals negative 1/3 x plus 2. And there is the equation of your tangent line. All right. So hopefully all this is making sense. And look, finding these equations of these tangent lines, okay, it's really not a lot of work once you get on into the calculus class, because finding the derivatives is going to be a lot easier than what we're doing now, what you're doing right now in this video. Okay. All right. So let's go ahead and take a look at this. We've got function f is a position function. Okay, so that tells us where an object is at any particular time. So in the time interval t equals a to t equals a plus h, the change in position is f of a plus h minus f of a. Okay, so, that makes sense. Okay, so, the y coordinate, that's going to give you where your position is. So if you subtract that 2, that's the change in your position. The average velocity over this time interval is, and the average velocity is equal to displacement over time. So that's f of a plus h minus f of a over h. All right. So really what you're doing here, you're doing f of a plus h minus f of a over a plus h minus a. You see that? So see, here's your two times right here, the a and the a plus h. So it's the displacement, which we saw that just a while ago here. So that's f of a plus h minus f of a over the time interval. So the time is this time minus this time, and you can see the a's cancel out, and that's where that h comes from. Okay, so that's your average velocity. Okay, the instantaneous velocity at time t equals a is v of a is equal to the limit as h goes to 0 of f of a plus h minus f of a over 8. All right, so you might be thinking, well, you know what? This right here and this right here looks the same, doesn't it? But there is a difference, okay? You see the difference between the average velocity and instantaneous velocity? The instantaneous velocity, yeah, it's this, but it's as h goes to 0, okay? We're taking the limit as h goes to 0. That'll give us the instantaneous velocity. All right, so let's look at an example. It says, suppose that a ball is dropped from the upper observation deck of the CN Tower 450 meters above the ground. What is the velocity of the ball after 5 seconds, and how fast is the ball traveling when it hits the ground? Okay, so you notice here they don't give us a formula. Well, the function s, we call that's typically what you're going to see the displacement function called, position function. That's what you're going to see it called is s. That's how you, s is displacement function, v would be your velocity, and we'll get into later on, a would be your acceleration. So s, which is f of t, I mean, you can call it f of t, it doesn't matter. That is 4.9 t squared. All right. So you might be thinking, well, how did you know that? Where did that come from? Well, they'll give you that in the problem. Okay. Later on, you'll learn how to find that function. Okay. That's in later on in calculus class. All right. So we want to know what is the velocity of the ball after 5 seconds. All right, so we've got to find the velocity. So we've got to do v of a as the limit f of a plus h minus f of a over h as h goes to 0. All right, so instead of finding the velocity right at 5 seconds and putting the 5 in for a, okay, instead of doing that, let's do this. Let's find v of t. Okay, so that's for any time. So, you know, if they come up and they say, okay, so for instance, this wants the velocity of the ball after 5 seconds, and then let's say part B would say, okay, what's the velocity at 7 seconds? What's the velocity at 9 seconds? Well, you don't want to have to keep doing this over and over and putting in the 5 and then the 7 and then the 9 and or whatever. So what we can do is we're going to say, okay, we're going to find this velocity function at any time t. And then once I find that velocity function, then all I have to do is just plug however many seconds, whatever time they want into there. All right. So this is going to be the limit as h goes to 0 of f of t plus h minus f of t over h. Okay, so instead of finding right at 5 seconds right now, I'm saying, okay, I'm going to find the velocity of the ball after t seconds. So this a I'm replacing with the t. Okay, so that's just going to give me the velocity function, and then I can like I said, just plug in any time I want after that. All right. So this is going to give me the limit as h goes to 0 of f of t plus h. So the t plus h, I'm going to plug that in for t. So that's going to be 4.9 times t plus h squared minus f of t, which is 4.9 t squared over h. And so this is going to be the limit as h goes to 0 of 4.9. And then this I've got to multiply out. Remember, t minus h squared is t plus h times t plus h, and I've got to multiply that out. So that's t squared plus 2th plus h squared minus 4.9 t squared over h. And so that's the limit as h goes to 0. Now look, if I distribute the 4.9, that's going to be 4.9 t squared minus 4.9 t squared. So those are going to go out. All right. So the 4.9 times 2, that's going to give me what? 9.8 th plus 4.9 h squared over h. And so this is going to be the limit as h goes to 0 of h times 9.8 t plus 4.9h, that's a t there, over h. The h's cancel, and that's the limit as h goes to 0 of 9.8t plus 4.9h. Plug the 0 in for h, that's going to be 9.8t plus 4.9 times 0, which is 9.8t. So what does that do? That tells me my velocity function is 9.8t. Okay, so what do they want to know? They want to know what is the velocity after t seconds. What is the velocity after t seconds? So for part A, that's going to be v of 5. Now after 5 seconds, so v of 5 is equal to 9.8 times 5, which that is going to give me 49 meters per second. And that's my velocity after 5 seconds. So that answers part A. Part B, how fast is the ball traveling when it hits the ground? Okay, so for part B. Okay, so when it hits the ground, okay, that's, okay, so think about this. The ball is what? It's 450 meters above ground. Okay? So it's at the top of this deck. All right, so you're up here. And when that ball is dropped, it hits the ground down here after what? After it's traveled 450 meters. So we need to know when is this position function, 4.9 t squared, that tells you the height of the ball. When does 4.9 t squared, when does that equal 450? When has that distance that it's traveled, when is that equal to 450? Because that's how far it has to fall before it hits the ground. So I get t squared is equal to 450 over 4.9. And so this tells me that t is equal to the square root of 450 over 4.9. Okay, that's the time that ball, that's at what time the ball hits the ground, which if we put that in our calculator, that's about 9.6 seconds. And so now to find the velocity, well, the velocity is equal, the velocity when it hits the ground is the velocity evaluated at the 9.6. Okay, so you see, by finding the velocity function like we did, where is it? There it is. Let me underline it. By finding that, well, here it is. By finding that velocity function like we did, see, if I wouldn't have done this, if I wouldn't have found the velocity function like this right here, then what would I have? I would have had to have done what? I would have had to have gone back through this again, plugging in the 9.6 for t. See, first, if I would have done the 5, I would have plugged the 5 in here. And then that would have given me the velocity at 5. That I would have gotten the 49 meters per second. Okay? But then I would have had to have gone through all of this again with 9.6 plugged in for t. So instead of doing it twice, I just did it one time with t in there just to get my function. And so now this is going to be, let's see, what is it? It's going to be 9.8 times 9.6. And that is going to give me, let's see, 9.8 times 9.6, that is 94.08 meters per second. That's the velocity at which it hits the ground. Okay? All right, so basically all we're doing, we're finding the derivative is what we're doing. Okay? All right, so definition, the derivative of a function f at a number a denoted by f prime of a. This is probably the more common notation you'll see for derivative. F prime is f prime of a is the limit as h goes to 0 of f of a plus h minus f of a over h. Okay, so that's what we saw just a while ago, finding that instantaneous velocity. Okay, that's finding the derivative of a function. Okay. That's what we're doing, finding the derivative. Okay, what do you think the derivative is? Well, we know it's the slope. It's what? It's the slope of a line, right? Slope of a tangent line at a point. All right. The derivative, which you'll see later on in the video, well, the derivative is rate of change. All right. So let's look at this. Find the derivative of the function f of x equals x squared minus 8x plus 9 at the number a. Okay, so at any point a, at any number, which this is good. We're just gonna, we're gonna find this with the a, and then whatever a is, whether it's 1, 2, 0.1, 0.3, whatever it is, we can just plug it into that function we find. All right, so let's go ahead and do that. So I've got f prime of a is equal to the limit as h goes to 0 of f of a plus h, f of a plus h minus f of a, all that over h. That's what we're looking for. So let's see what we get. So this is going to be the limit as h goes to 0 of, let's see, f of a plus h. So each one of the x values here I'm going to replace with a plus h. So that's a plus h squared minus 8 times a plus h plus 9 minus f of a. Okay, well, what's f of a? Let's come up here. F of a is equal to a squared minus 8 minus 8a plus 9, right? So that's a squared minus 8a plus 9, all that over h. And so this is going to be the limit as h goes to 0. And I'm going to multiply this out. A plus h times a plus h. That's a squared plus 2ah plus h squared minus 8a minus 8h plus 9. Then distribute the negative, minus a squared plus 8a minus 9. All that over h. And that's going to be the limit as h goes to 0. So let's see what happens. The a squareds go out, the 8a goes out, and the 9's go out. Okay, so that's going to be 2ah plus h squared minus 8h over h. And so that's going to be the limit as h goes to 0. I'll factor out a h, 2a plus h minus 8 over h, and the h's cancel. So that's the limit as h goes to 0 of 2a plus h minus 8. So that's 2a plus 0 minus 8, which is 2a minus 8. Okay, so our derivative f prime of a is equal to 2a minus 8. And that's what they were wanting in that problem, the derivative at a. and really, you know, if you get this, then the next video or the next section in your calculus class, it's going to be pretty easy because it's this, but instead of a, it's going to be an x there. Okay. All right, so here they want us to find the equation of the tangent line to the parabola y equals x squared minus 8x plus 9 at the point 3, negative 6. Okay. Now, just think about this for a minute. Okay, if you're taking notes, don't write this down. The limit as h goes to 0, and that would be what? That would be f of 3 plus h minus f of 3 over h. All right, and you would have to take this and plug it in for the x's and then find f of 3 and all that stuff. Now, I know this is y, so it'd be y of that. Okay, and you would have to go through all that process there. But see, finding the derivative at some number a, just any number, well, look, did you notice that this is the same function and we found the derivative at just some number a and we ended up with this? You see that? So what does that do? Does that make our life easier by just doing that? Of course it does. So the slope, remember, it's just the derivative evaluated at that point. So that's, in this case, that's what, y prime of 3, right? Now, I don't know why the book changed it to y, but anyway, you're just taking this and plugging it into there. So that's 2 times 3 minus 8, which that gives us negative 2. So there's the slope of your tangent line, negative 2. All right, so now we can use y minus y1 equals m times x minus x1. And so we've got y, let's see, y plus 6 equals negative 2 times x minus 3. And so that's y plus 6 equals negative 2x plus 6. So y equals negative 2x. And there's the slope, and there's the equation of the tangent line. So putting all this together, finding the equation of a tangent line, you're finding the slope, okay, by finding the derivative of that function and then evaluating that function at that point. And then using the point slope formula from algebra. That's all you're doing here. Okay. So we've got some stuff here. Let's see, rates of change. So suppose y is a quantity that depends on another quantity x. Thus, y is a function of x, and we write y equals f of x. If x changes from x1 to x2, then the change in x is, and we use a delta x equals x2 minus x1, and then the corresponding change in y is delta y is equal to f of x2 minus f of x1. The difference quotient, delta y over delta x, which is f of x2 minus f of x1 over x2 minus x1, is called the average rate of change of y with respect to x over the time interval x1 to x2. Okay, so there's your average rate of change. All right, so if you're over this time interval here, x1 to x2, then it's the function evaluated at this one minus the function evaluated at this one over this time minus this time, the x2 minus x1. That's going to give you your average rate of change. And then your instantaneous rate of change, you're just doing this, but you're taking the limit of it as x2 approaches x1 because we want this denominator to go to 0. All right. See, it's just like up here. See, they're just writing the x2 minus x1 up there or down there in that problem at the end. They're just writing that x2 minus x1 there. But see, it's just we're wanting that denominator, find that instantaneous rate of change. We're wanting that denominator to go to 0. Okay, and that's why x2 is approaching x1 to make that go to 0. Okay, and so the derivative f prime of a is the instantaneous rate of change of y equals f of x with respect to x when x equals a. All right, so finding the derivative, it's a rate of change. Okay, so this video, it wasn't quite as long as I thought it would be. It's important that you know how to do this stuff. But like I said, in the next video, you're going to be taking derivatives using the limit. Okay, and you know that's more of what you're going to do. You know, just finding your derivative, finding the function, and then plugging the numbers into it. Okay, pretty kind of like what we did right here in this. Okay, except like I said, the difference that you'll have is in the next video, this will be f of x plus h in f of x. And so basically what you'll do is you'll get your derivative f prime of x, which you would get 2x minus 8 instead of 2a minus 8. Okay, that's one of the main differences in the next section or the next video. Okay, so you know, watch the next one, and then after that video, then we'll get into the stuff of finding derivatives using like power rule, product rule, quotient rule, chain rule, do implicit differentiation, do all the good stuff. Okay, easy ways to find the derivative instead of going through all this mess right here. Okay, all right, so I hope the video helped. Check out my other videos, give me a like, share, and subscribe. Thanks for watching. See ya.